Where is gold found on Earth? Gold has captured human imagination since the dawn of civilization. From ancient temples covered in golden ornaments to the global economies that relied on gold standards, this unique element has shaped the course of human history. Yet behind its brilliance lies a deeper question: where does gold actually come from, and where is it found on Earth today? The answer is not simple, because gold is the product of rare geological processes, distributed unevenly across our planet. To understand its occurrence, one must explore not only the rocks and minerals that host it, but also the tectonic forces, climatic conditions, and human endeavors that have concentrated gold into the deposits we know today. 1. The cosmic origins of gold. Gold is not originally from Earth's surface. Like many heavy elements, gold was formed in violent cosmic events, most likely supernova explosions and neutron star collisions. Billions of years ago, during the early stages of Earth's formation, meteorites delivered much of this gold to the young planet. Some sank deep into the mantle and core, while smaller amounts remained trapped in the crust. This extraterrestrial origin makes every grain of gold we see today not just a mineral resource, but a fragment of cosmic history. When ancient civilizations worshipped gold as a divine metal, they were, unknowingly, venerating a material forged in the stars. 2. Primary gold deposits, lodes and veins. Gold in its natural geological setting is most often found in primary deposits, known as lode deposits. These form when hot, mineral-rich fluids travel through fractures in the Earth's crust. As the fluids cool, they leave behind veins of quartz laced with gold. In some places, the gold appears as large, visible nuggets embedded in quartz. In others, it is microscopic, requiring crushing and chemical extraction to recover. These deposits are frequently associated with other minerals such as pyrite, chalcopyrite, and arsenopyrite, which act as hosts for invisible or finely dispersed gold particles. Notable lode deposits include Witwatersrand Basin, South Africa, producing over 40% of all gold mined in human history. Carlin Trend, Nevada, USA, famous for its microscopic, invisible gold, which occurs inside sulfide minerals. Kalgoorlie, Western Australia, one of the richest gold districts in the Southern Hemisphere. 3. Secondary gold deposits, placer gold. When exposed to weathering, primary deposits break down and release gold particles. Because gold is extremely dense and chemically stable, it resists corrosion and tends to accumulate in rivers, streams, and floodplains. These are known as placer deposits. Placer gold appears as flakes, fine dust, or water-worn nuggets. Throughout history, placer deposits have been easier to mine, as they require less technology than hard rock mining. Entire societies were transformed by such discoveries. The California Gold Rush, 1848 to 1855, triggered mass migration and the growth of San Francisco. The Klondike Gold Rush, 1896, drew thousands to the remote Yukon Territory in Canada. In Australia, the discovery of massive gold nuggets in the 1850s led to the expansion of Melbourne and Sydney. These secondary deposits demonstrate how geology directly influenced human settlement patterns, economies, and even political systems. 4. Tectonics and gold distribution. Gold is not randomly scattered across the globe. Its occurrence is tied to Earth's tectonic architecture. Subduction zones, where one tectonic plate is forced beneath another, create heat and pressure that drive hydrothermal activity. These environments are ideal for concentrating gold. Collision zones between continents also generate gold-bearing mountain belts, as fluids circulate during the uplift and metamorphism of rocks. Ancient orogenic belts, sometimes billions of years old, preserve some of the richest gold fields still mined today. Prominent examples include the Pacific Ring of Fire, home to giant gold deposits in Papua New Guinea, Indonesia, and the Americas. The Canadian Shield, one of the oldest geological regions on Earth, hosting numerous Archean-age gold deposits. The Ural Mountains, Russia, known since antiquity as a source of gold and precious metals. 5. gold beneath the oceans. An often overlooked source of gold lies beneath the oceans. Seawater itself contains dissolved gold, though in concentrations far too low to be extracted economically. More promising are seafloor massive sulfide deposits, created by hydrothermal vents on the ocean floor. These deposits contain gold, silver, copper, and zinc, but their mining presents immense technical and environmental challenges. Future generations may unlock these resources, but the ecological risks of disturbing deep-sea ecosystems remain a serious concern. 6. Modern gold mining and technology. Today, gold mining takes place on every continent except Antarctica. Modern techniques range from large-scale open-pit mines to underground operations. In regions such as Nevada, cyanide leaching is used to extract microscopic gold particles from low-grade ore, while in places like South Africa, deep underground mines reach depths of more than 3 kilometers. Advances in satellite imaging, geophysical surveys, and geochemical analysis allow geologists to locate new deposits with greater precision. However, despite these technologies, the discovery of large, high-grade deposits has become increasingly rare, highlighting the geological scarcity of gold. 7. Environmental and social dimensions. Gold has a complex legacy. While it fueled economic growth and technological advancement, gold mining also left scars on landscapes and communities. Mercury pollution from artisanal mining, deforestation in the Amazon, and toxic tailings from industrial mines are ongoing concerns. Yet gold continues to play a vital role in modern life. Beyond jewelry and investment, gold is essential in electronics, medical devices, renewable energy technology, and even aerospace engineering. Its combination of conductivity, malleability, and resistance to corrosion makes it irreplaceable in many applications. 8. The future of gold exploration. As traditional deposits become depleted, geologists are looking deeper, exploring remote terrains, and even considering space mining. Asteroids are thought to contain enormous quantities of precious metals, including gold. While still science fiction today, the idea that humanity may one day mine gold beyond Earth highlights how deeply this metal remains tied to progress and ambition. Conclusion. Gold's story is a tapestry woven from cosmic explosions, tectonic shifts, river currents, and human dreams. It is found in quartz veins deep underground, in riverbeds shaped by time, on the seafloor, and possibly in the stars above. Its rarity and beauty ensured its place as both a cultural symbol and a technological necessity. To ask, where is gold found on Earth, is to open the pages of a geological and human history that stretches from the birth of the planet to the modern digital age. Gold is not merely a metal, it is the meeting point of Earth's deepest forces and humanity's greatest ambitions.